Good morning everybody. Here is in my channel Proper Guidance. This is a guidance to CBSE Board Computer Science. Here we are to discuss chapter number 2. Already we have taken 2 classes about introduction to number system and conversion of number system. In today's class we will discuss about conversion of a number with fractional part. We are following here NCERT study material, and here is detailed discussion about the chapters and the question answers. Okay, so today we are discussing about the conversion of a number with fractional part. Now see, till now we largely dealt with different conversions for whole number. In this section we will learn about conversion of numbers with a fractional part. Now see, first of all, decimal number with fractional part to another number system. Decimal number with fractional part to another number system. To convert the fractional part of a decimal number to another number system with base value b, repeatedly multiply the fractional part by the base value b till the fractional part becomes 0. Use integer part from top to bottom to get equivalent number in that number system. Okay, these are the steps to complete the calculation. Now we can understand it with the help of this example. Here is an example: convert 0.25 to the base 10 to binary number. Now see, this is a fractional part and 0.25. Now we have to convert the decimal number to its equivalent binary number. Now the base of decimal number is 10 and for binary number this is 2. We are converting from decimal to binary, and the required number system is here binary number system, and that the base of binary number system is 2. That's why we have to multiply 0.25 with 2. That is 0.25 into 2 is equal to 0.50, and again 0.50 into 2 equals to 1.00. We have to multiply. Here is the part. See, part of a decimal number to another number system with base value b, repeatedly multiply the fractional part by the base value b till the fractional part becomes 0. How much we have to multiply? How many times? We have to multiply the fractional part until it becomes 0. Here we can see that the fractional part is become 0.00, and that's why we stop the multiplication further and we get the integer part here. And we will take here from top to bottom. We will take here the values from top to bottom. For whole number we are collecting the what was the procedure? We divide it by 2 and then we are collecting the remainders. Here we just took the integer part. See, 0.25 into 2 equals to 0.50, so integer part here is 0. We are taken as integer part, the value is 0 here, and second part, that is 1, and we are taking here 1. Since the fractional part is 0, the multiplication is stopped. Write the integer part from top to bottom to get binary number for the fractional part, and therefore 0.25 to the base 10 equals to 0.01 to the base 2. So the equivalent binary number of the fractional part 0.25 to the base 10 is equal to 0.01 to the base 2. So this is an example to how to convert a fractional number to its equivalent another system of binary, another number. Here it is a binary number. And here is another example. Same procedure, we have to convert the fractional part to its equivalent binary number. Same procedure, we have to multiply with 2 and we are getting these values here and taking the integer part here. The integer part will come either 1 or 0. Okay, and after that we again get, see, look here, we have to multiply this one until the fractional part becomes 0. But in this example, first value and the third value 0.400 is here, and integer part is collected as 1, and then it becomes 0.800, then 0.600, then 0.200, and again it comes 0.400. Since the fractional part 0.400 is the repeating value in the calculation, the multiplication is stopped here. Though the fractional part is not 0, but this is repeating value, and that's why the multiplication is stopped. Write the integer part from top to bottom to get binary number for the fractional part. Therefore 0.675 to the base 10 equals to, we are collecting like from top to bottom approach, 0.1010101110 to the base 2. Okay, and then this part we have done here, decimal to binary number, fractional part, and here we will learn how to convert, just wait for a moment, how to convert decimal to octal number system. For binary number system, what was the procedure? We have to multiply with 2 because the base value of binary number system is 2. Here in octal number system the base value is 8, so we have to multiply the fractional part with 8 until it becomes 0, fractional part becomes 0. And in this example 675 to the base 10 to octal, we are multiplying this. Look at the example. First part 5.400 and then 3.200, and here integer part is collected in this side. Integer part, first number 5, then 3, then 1, then 4, and then 6. Why we stop multiplying? Because again in this example we get the fractional part as 4.400, the same for the first fractional part, right? So we have to stop here. The multiplication is stopped, and we will collect from top to bottom 53146 to the base 8, and this is the required octal number of the fractional part here. And convert this to hexadecimal form. Same procedure for hexadecimal. We know the base value of hexadecimal is what? 16. So we have to multiply the fractional part with 16 until it becomes 00. But here we get that 0.675 into 16 equals to 10.800. Again it comes 0.800. So we stop here. Repeating, since the fractional part is repeating, the multiplication is stopped. Write the integer part from top to bottom to get hexadecimal equivalent for the fractional part. And here we all know that 10 is equivalent to A and 12 is equivalent to C, and therefore 0.675 to the base 10 equals to 0.AC to the base 16. So we are already discussed the total portion, fractional part to binary to octal and to hexadecimal. From what? From decimal number system. Now non-decimal number with fractional part to decimal number system. This is very important. Non-decimal number to fractional part to decimal number. What is the procedure? We are using here positional value and the digit to get the equivalent decimal number with fractional part. We will discuss this matter with an help of example. See, convert 100,101.101 to the base 2 into its equivalent decimal. So write down the digit here, and here is the point, and here is the fractional part 101. And we all know using the positional value from the left hand side, from the left hand side of the decimal point, we use the powers of 2 like this: 2 to the power 0, 2 to the power 1, 2 to the power, look here, 2 to the power 0, then 2 to the power 1, 2 square, 2 cube, 2 to the power 4 and 2 to the power 5. And same as in the right hand side of the decimal point, 2 to the power minus 1, 2 to the power minus 2 and 2 to the power minus 3. After calculating this, we get all these values and the final value would be 37.625 to the base 10. This is the procedure to convert with the help of positional value, binary to decimal. And octal to decimal, same procedure. Instead of 2, we use here 8, because for octal the base value is 8, and same thing done here. You please go through all these examples. If there is any query, please ask me and comment me. I will definitely clear all the doubts. This is very important part of conversion, right? Now fractional binary number to octal or hexadecimal number. Fractional binary number, how to convert? How to convert a fractional binary number to octal number? Before this class, we have already discussed in a previous class grouping of 3 bits, right? Grouping of 3 bits. Here we also use that procedure, grouping of 3 bits. Make a perfect group of 3 bits. Write this. First we take the given value here, then we group like this from this side, right to left, and then left to right. For the left hand side of the point, the decimal point number, we will group like this: first 001, then 101, then 010, and our right hand side here 010 and 110. Look, we have just 2 digits, right? 11, and grouping should be of 3 bits, so we add an extra 0 here. 0 after decimal point has no values, right? So we can add here, and after that we should write all the values, respective values in octal number system, and we get the resultant value 254.26 to the base 8. And convert the binary number to its equivalent hexadecimal number. Make perfect group of 4 bits. We have already done in the previous class of grouping of 4 bits, and convert it to its equivalent hexadecimal number. Here we also done like this, making grouping of 4 bits and then write down the equivalent hexadecimal number here, and we get the resultant value AC.5C to the base 16. Okay, so chapter 2 is completed here. The entire chapter is completed with detailed explanation. If there is any query regarding this, you please ask me and comment me, and if you think that this video is helpful for you, please like and share, and please subscribe my channel for any further notification. And you please do one thing, there are so many questions, these questions are very important. You please take this as homework, right? Homework, you do this in your exercise book. If there is any problem, kindly ask me. I will definitely solve that one for you. Thank you.